Now that we know how to find area under a polar curve, the next logical thing to do, take a look at the area between two polar curves. So let's take a look at a quick polar graph. Let's say I'm interested in the area between theta 1 and theta 2. And I'm going to call this R1 of theta. And this one R2 of theta. Well, what we did in rectangular coordinates is we said, well, just take the big one, do the integration, subtract from it the little one, right? And that gives you the area between them. And that's exactly the same approach we're going to do here. Because if I integrate from theta 1 to theta 2, 1/2 of R1 squared of theta, that will give me all of this area here. But it's too much. And how much too much is it? It's the area from theta 1 to theta 2 under R2 of theta. This. So if I simply set those up and subtract the two, I'll get the piece that I want. So what that tells us is that the area between two curves then is going to be equal to 1/2 the integral from theta 1 to theta 2 of R1 squared of theta minus R2 squared of theta d theta for R1 of theta greater than or equal to R2 of theta. Now obviously if we have a situation between theta 1 and theta 2, the area that we're interested in, where they change places, then we need to break it up into individual integrals and simply take these two and switch places. It's the exact same thing we did in rectangular coordinates, so there's no new concept there. So really that's all that we have to do. So let's go ahead and take a look at a quick example. I'm interested in the area between r equals 2 and r equals 1 plus 2 cosine of theta. And what I'm interested in is this area right here. So what I need to find is where is it that these guys intersect. Because I really need these two angles. Well, I'm going to solve that just like you'd expect. Set them equal to each other. 2 equals 1 plus 2 cosine of theta. That implies that 1 is equal to 2 cosine of theta, which means that 1/2 is then equal to cosine of theta. Now, cosine of theta equals 1/2 when theta equals plus and minus pi over 3. So this could be a negative pi over 3, and this would be a pi over 3. So if I start here, this will in fact trace out and give me that piece that I need. But what I'm going to do is I'm going to use the symmetry that I can see here. And I'm simply going to go from 0 to pi over 3 and multiply it by 2. And use the symmetry. If I can start at theta equals 0 or end at theta equals 0, I tend to try to do that because I think it makes life a little bit easier in terms of evaluation. So my area should be equal to, I'm using symmetry, so I'm going to say it's twice 1/2 the integral from 0 to pi over 3 of R1, which is the big one, which is 1 plus 2 cosine of theta squared minus R2, the smaller one, which is just 2 squared. So that's going to be equal to, well, the 2 is going to cancel. The integral, I'm going to stop right in 0 to pi over 3 for the next couple steps. You know it belongs there. I'm just going to save a few strokes here. The integral, obviously, I have 1 plus 4 cosine of theta plus 4 cosine squared of theta minus 4 d theta. Well, clearly these can't come together and give me a negative 3. So this is going to be the integral of negative 3 plus 4 cosine of theta plus 4 times 1 plus cosine of 2 theta over 2 d theta. Go ahead and distribute that 4. This will be the integral of negative 3 plus 4 cosine of theta plus, I'll have 1/2. 4 times 1/2, that's 2. Plus 4 cosine 2 theta over 2, that's 2 cosine 2 theta d theta. So obviously these are going to cancel out and give me just simply a -1. So what I'm going to actually integrate from 0 to pi over 3 is a -1 plus 4 cosine theta plus 2 cosine 2 theta d theta. That's going to be equal to a negative theta plus 4 sine theta plus sine 2 theta evaluated from 0 to pi over 3. Now see all these sines and just the theta by itself, using symmetry, so I have 0 as one of my angles in there, is going to pay off. Because when I take that second evaluation, all these are going to be 0. So really all I need to do is evaluate this at pi over 3. So this is going to be equal to a negative pi over 3 plus 4 times sine of pi over 3 is root 3 over 2 plus sine of 2 pi over 3, that's still root 3 over 2. And there's my solution. I mean, I should simplify it, work with it a little bit. That's going to cancel, give me a 2. So I'll have 2 root 3 plus root 3 over 2 minus pi over 3, which is going to be 5 root 3 over 2 minus pi over 3, which to me is fine. Or you could say this is going to be 15 root 3 minus 2 pi over 6. I'm good at that point. But anyway, there you go. There's your solution.